Hi and hello. You are watching High Physics channel. I'm Karthikeyan. This science video is intended for CBSE and State Board Grade 7 students. In this video, we are going to cover the lesson electric current and its effect. In this, we are going to see what you mean by electric current, what do you mean by electric circuit, how to draw a circuit diagram, and what are all the symbols, basic symbols for drawing a circuit diagram. And we are going to see one heating effect of electric current and the application of this effect, that is safety fuse or electrical fuse. So this is how this video has been planned. We all know that electricity is a natural force discovered by Benjamin Franklin in the year 1752. He demonstrated that charge flowed through a metal using a famous kite experiment. In this experiment, he flew a kite on a thunderstorm day, and when lightning struck, the electrical charge passed through the metal piece to his arm, and so he felt a minor shock in his arm. And this is how he demonstrated that charge flowed through a charge passed through a metal piece. Now we are going to see how to define the direction of an electric current. The circuit here, the second circuit diagram, we have a small metal piece connected by a wire to a battery. This longer, lengthier line indicates the positive terminal of the battery, and the short fat line indicates the negative terminal of the battery. So as the battery is connected to the metal piece, the battery supplies the energy so that electrons are pumped out of this metal piece towards the positive terminal of the battery. And similarly, electrons from the negative terminal flowed into the metal piece. So this is the direction through which electron flowed. But the convention is that conventional current flow direction is opposite to the direction of the electron flow. So here the electron flows in this direction. Therefore, the current direction is in this direction, opposite to the direction of the flow of electrons. So this is the convention followed by Benjamin Franklin, and till date we follow this convention. So what is an electric circuit? The unbroken path through which an electric current can flow is called an electric circuit. The key word is unbroken path. That is, the path, there should not be any gap. So unbroken path through which an electric current flows is called an electric circuit. Here a simple electric circuit is shown for you. This is an incandescent bulb connected to a cell, and this cell is connected through a switch which is in the on position or the closed position. So here there is no gap. As a result, the current flows from the cell to the incandescent bulb, and as a result the incandescent bulb glows. So how to draw this circuit? Drawing of an electrical circuit with standard symbol is called circuit diagram. We cannot draw a bulb, we cannot draw a switch, we cannot draw a cell as it is. So we need some standard symbol to represent all these things. So when we draw a diagram using this symbol, then this circuit diagram is called as, this electrical circuit is called as a circuit diagram. Here we have shown the symbol for an electric bulb, and this is the symbol for the switch, which is in the closed position since it is connected. So since the two dots are connected, this is called as the closed position of the switch, and this is the battery or the cell. This lengthier line represents the positive, and the shorter line represents the negative terminal of the battery. And as a result, current flows through the closed circuit. As a result, the bulb glows. Here in the next adjacent diagram, the switch is in the open position. That means there is a gap. So current will not flow through this circuit. As a result, bulb will not glow. So a drawing of an electrical circuit with standard symbol is called a circuit diagram. So we need symbols to represent a circuit diagram. So electric cell, as we have seen earlier, is represented by this diagram. A lengthier line and a shorter line is called as the cell. Positive and negative terminal of the cell is represented like this. Then an electrical bulb is represented like this, and closed position of the switch, then this is the open position of the switch. And if you connect more than one cell, more than two cells are connected together, then it forms a battery. So we can represent the battery in this form, and the wire is represented by a straight line. And there are many more symbols, but this is the basic circuit symbols which we need for this 7th grade class. How to connect cells to make a battery? Combination of two or more cells is called a battery, as I said earlier. And to form a battery, we have to connect two or more cells. How this connection is made? The negative terminal of the first cell is connected to the positive terminal of the second cell, and the negative terminal of the second cell is connected to the positive terminal of the third cell, and similarly the negative terminal of the third cell is connected to the positive terminal of the fourth cell. Right? The negative terminal is connected to the positive terminal of the adjacent cell. So we can form a battery. Or the simple way is to have a cell holder, and we can comfortably place the cells in these slots, and internal connections are made with metallic contacts and wires, so that we may get a battery connection here with 3 or 4 cells put together. Now we go to see the heating effect of an electric current. This we know, this is an incandescent bulb, right? When electricity flows through this incandescent bulb, there is a small, tiny, thin filament, right, which is made up of tungsten. This small metal wire, thin metal wire, we call it as the filament, is made up of tungsten, right? When current flows through this incandescent bulb, it heats the tungsten filament. As a result, the tungsten filament glows, and then the bulb emits light. So here you have two effects. One is light is emitted, as well as the filament is getting heated. Whenever a current flows through a metal piece or a metal wire, the metal wire or the metal piece gets heated up. This effect is called as the heating effect. This is a disadvantage because some part of the electrical energy is used up for producing the heat. We are intended to produce light, but the side effect, as a side effect, we have produced heat also. This is a disadvantage. How to turn this disadvantage into an advantage? We have many electrical appliances which uses this heat energy. For example, electrical iron box. Here in this electrical iron box, you have tightly wound coils, which we call it as elements. So these elements gets heated up as electricity flows through it, and this heat is used in this iron box. Similarly, in this electric heating stove or the electric heater, the elements are heated, and the element glows, thereby producing the heat. So this is a disadvantage. Heating effect is a disadvantage, but turned into an advantage. How this heating effect is produced? When a current flows through a metal wire, what happens is that the electrons flows from the metal piece to the positive terminal of the battery. As it flows, it collides with the atoms of the metal. As a result, the atoms of the metals vibrate, thereby producing the heating effect as shown in the diagram. Now, how to use this effect as an application? Electric fuse or the safety fuse is the important application of this electrical heating effect. Right? In this electrical, we may find this electrical fuse in a meter box in our homes. Right? Here in this electric fuse, you have two metallic contacts which is connected by a thin wire made up of lead, tin, or alloys of lead and tin. So this thin wire, current can flow through this thin wire and make a complete circuit. But whenever excess of current flows, then this thin wire gets heated up and melts. As a result, there is a gap produced so that the electric current cannot flow through the device. For example, if this fuse is rated as 20 amp, the unit for electric current is amperes, we call it as amp, and if this rating is 20 ampere, then only up to 20 ampere current can flow through this wire. If more than this, say 21 or 22 ampere current flows through this circuit, then the wire melts, thus breaking the contact. As a result, no current will flow, thereby protecting our home and our valuable electrical appliances. What is the principle behind this electric fuse? The principle behind this electric fuse is a heating effect of electric current. And this is the symbol for drawing a fuse in a circuit diagram. So this is the symbol, standard symbol for a fuse. And this here we have represented another form of a fuse, which we call it as the cartridge fuse, which is available in our devices, in many devices, electrical and electronic devices. So summary, what we have seen in this video, we have seen electric current, we have seen circuit diagram, how to draw a circuit diagram with standard symbols, and we have seen one effect called as the heating effect of the electric current and the application of this heating effect of the electric current, that is safety fuse or electrical fuse. In the subsequent videos, we will be discussing electromagnetic effect of the electric current. Kindly subscribe to this channel, like this channel, share this channel by clicking the bell button. Thank you for watching.